Hello, everyone, and welcome to my channel, Empowering Finance with Technology, where we combine the power of finance and data analytics to make complex concepts simple and practical. My name is Arnab Datta, and in today's special session, we shall bring together 5 of our tutorials on basic DAX concepts plus 30 more useful DAX functions all in one complete video. If you are just starting your DAX journey, this compilation is the perfect place to begin. I'm assuming that all of you have a good knowledge of Power Query. If not, I would request you to first go through my tutorial on Power Query. Please click the I button and click the link given in the description. We shall start with the fundamentals. What DAX is, how it differs from Excel formulas, and why it is such a game changer for data analysis. Then we shall move into key building blocks such as Aggregator and Iterator functions, learning how DAX processes data differently behind the scenes. Next, we shall see how DAX and data model together outperform the traditional Excel calculations, especially when working with large dynamic datasets. We shall explore the power of variables in DAX, learning how to simplify complex formulas and make our code cleaner, faster, easier to maintain. We shall also dive into some common yet confusing topics like the difference between values and distinct, uncovering how they actually behave in different contexts. And finally, we shall explain top 30 DAX functions to supercharge your Power Pivot in Excel. By the end of this video, you will have a solid foundation in DAX, understanding not just how to write formulas, but how DAX thinks and calculates behind the scenes. So, whether you are a finance professional, data analyst, or Power Pivot enthusiast, sit back, relax, and get ready to master the basics of DAX with practical examples, clear explanation, and real world insights. So, let's get started.
What is DAX? DAX, Data Analysis Expression, is a specialized formula language used in Microsoft Power BI analysis services and Power Pivot for Excel. Designed for data modeling and analysis, DAX enables users to create powerful calculations, aggregations, and custom measures within the data models. While DAX is relatively simple to learn, it differs significantly from traditional programming languages. Its syntax and logic are tailored for columnar data, filter contexts, and dynamic calculations, making it uniquely suited for analytical tasks rather than general-purpose programming. DAX data types are integer, decimal, currency, datetime, Boolean, string, binary, variant. Here is a list of DAX operators. Now we shall understand the difference between Excel and DAX formulas. Excel performs calculations over cells. A cell is referenced using its coordinates. In DAX, the concept of a cell and its coordinates does not exist. DAX works on tables and columns, not cells. As a consequence, DAX expressions refer to tables and columns, and this means writing code differently. In Excel, the concept of tables and columns are not new. In fact, if we define an Excel range as a table by using the format as table function, we can write formulas in Excel that reference tables and columns. Using Excel, we refer to columns in a table using the @column_name format. Column name is the name of the column to use, and the @symbol means take the value for the current row. Normally, we do not write these expressions. They appear when we click a cell, and Excel takes care of inserting the right code for us. Let us see the difference with a practical example. The first column is sales. The second column is target. Depending on whether sales is greater than target, the third column is filled by using simple Excel formula. The formula is if A2 greater than B2, then C2 should show achieved, else not achieved. Copy the formula to other rows of the table. We shall now copy-paste the first two columns and try to achieve the same by using Excel table formulas. After copy and pasting, we shall convert them into a table. Go to the right of the header of the pasted columns and write result. The table will automatically expanded include the third column. Now input the Excel table formula. Because it is table formula, all the rows are automatically filled in. Now we shall try to achieve the same result by using DAX. Copy the first 2 rows of the table and paste it on the right. Click Data on menu bar. Click from Table Range. The new table is already selected. Click OK. Power Query menu will open up. Click Close and Load to. A pop-up box will open. Select the radio button, Only Create Connections. Tick the option to add to the data model. Click OK. The data will be added to the data model. Click Data on the ribbon to get Data Model icon. Click Data Model to get a view of the data model. You can only apply DAX formulas in Data Model. Click the blank column to select. Click the header and type results. Select any row and input the DAX formula. The DAX formula will be copied into entire row. The results will be same as obtained in Excel. Before using DAX functions, it is important to remember that DAX is designed to work with tables and columns, not with individual cells like Excel. While DAX is very powerful and efficient at aggregating values across rows and columns, it is less straightforward when you need to aggregate values across columns and rows. For example, in Excel, if a company's monthly sales data is stored across cells A1 to J1, you can easily calculate yearly sales with a simple formula, sum A1, J1. In DAX, however, there is no direct equivalent of this column-wise summation in a single column. You would need to explicitly reference each column in your expression, as DAX does not provide a shortcut for this type of calculation. So do not use DAX for aggregation of multiple columnar data in a single column. We have gone directly into Data Model, where we see a table containing 3 columns B, C, and A. Create a calculated column, which will calculate row-wise total of columns B, C, and A. As explained earlier, DAX is designed to work on table and columns and not on rows. Click the header of the blank column and type total 2. There is no shortcut formula like sum, A2, C2 in DAX. We have to select each column and add up. Select the first row of the column. Input equals sign. Select the column A. Input plus sign. Select the column B, input plus sign. Select the column C, press enter. We have the row-wise total 2 in the total 2 column. Concept of aggregator versus iterator in DAX. In DAX, data analysis expressions, aggregators and iterators are two types of functions used for calculations in Power BI, Power Pivot, and analysis services. They differ in how they process data and their typical use cases. Aggregators. Definition: aggregators are DAX functions that perform calculations, like summing, averaging, counting, etc., over a set of rows in a table or column, automatically handling the context, filter, or row context, without explicitly iterating over each row. Behavior. They operate on an entire column or table and aggregate the values into a single result, respecting the current filter context. Common aggregators: sum, average, count, min, max, count rows, etc. Key characteristics: simple and concise. Automatically handle filter context. Do not explicitly loop through rows. Typically faster for straightforward calculations. Use case: when you need a single aggregated value, e.g. total sales, average price, across a column or table. Example of an aggregator. Suppose you have a table sales with columns product, quantity, and price. You want to calculate the total quantity. Total quantity equals sum sales quantity. Here, sum aggregates the quantity for all rows in the sales table, respecting any filters applied, e.g., by product or region. Iterators. Definition: iterators are DAX functions that loop through each row in a table, perform a calculation for each row, and then aggregate the results, e.g., sum, average, into a single value. Behavior. They explicitly iterate over rows, evaluate an expression for each row, and then combine the results based on the function's aggregation logic. Common iterators: sumx, averagex, minx, max, countx, renkx, filter, concatenatex, etc. Key characteristics: provide row-by-row control over calculations. More flexible for complex logic where row-level computation is needed. Can be slower than aggregators due to explicit row iteration. Work with an expression that is evaluated for each row. Use case: when you need to perform calculations that involve row-by-row logic or complex expressions before aggregating. Example of an iterator. Suppose you have a table sales with columns product, quantity, and price. You want to calculate the total sales amount. Total sales equals sumx, sales, sales price, asterisk sales quantity. Here sumx multiplies the price by quantity at each row to arrive at the sales value, and then aggregates to provide us the total sales value. We present a summary of the difference between the aggregator and iterator. When to use which. Use aggregators for simple, direct aggregations, e.g., total sales, average price, where no row-level logic is needed. Use iterators when you need to. Perform calculations on a row-by-row basis, e.g., apply discounts, conditional logic, that'll work with complex expressions that can't be handled by aggregators. Iterate over a filtered or virtual table, e.g., using filter or all. Now, we shall understand the difference between the aggregator and the iterator with an example. We have got a table which contains 6 products and their respective price and the quantity sold. First, we shall select the table, then go to Data, then Get Data from other sources. Click Table/Range. Power Query will open up. We shall then click Close and Load to. A pop-up box will open up. Click the radio button, Create Only Connection, and then tick Add Data to the data model. Click OK. The data will be loaded into the data model. From the ribbon, click Manage Data Model. Data Model will open up. We shall create the aggregate function. We need to find out the total quantity of sales of 6 products. Select any cell below the thick line. Name the measure as total quantity. In formula bar, type total quantity equals. Write sum, open the bracket, click quantity column, close bracket, press enter. We shall get measure total quantity, which is the sum of the quantity of all products sold. Now, we shall create an iterative measure, which will be total sales. Total sales does not appear in any column. So, what we shall do is use iterative measure sumx. In an iterative function, you will have to give two parameters. First is the table name, and second is the formula. We shall name the iterative function as total sales. In the formula bar, input total sales equals sumx. Open bracket. Provide the name of the table as sales, then put comma, the click price column. The input star. Click quantity column and close the bracket. We shall have the results for the total sales. Sum X aggregates on the product at each row and obtain the value of our total sales. We shall understand how DAX along with data model is superior to normal Excel with an example. Here, we have got a table which has got 3 columns. The first column contains the product details. The second column contains the sale prices, and the third column contains the cost of the product. We cannot directly get the gross profit and the gross profit percentage from this table. For this, we shall have to expand the table by creating 2 more columns. The gross profit and gross profit percentage. We shall compute the gross profit by subtracting cost from sales. We shall compute the gross profit percentage by dividing gross profit by sales. Format gross profit percentage column to 1 decimal. Here we have obtained the gross profit and gross profit percentage of each item sold. To do further analysis to find overall and category-wise gross profit and gross profit percentage, we shall have to create a pivot table. Select the entire table to insert a pivot table. From the pivot table fields, we shall select the fields products, sales, cost, gross profit, and gross profit percentage. While the gross profit is shown perfectly in the analysis, gross profit percentage is absolutely wrong as Excel just aggregated gross profit percentages. Let us color this column in red to show it is wrong. To find out gross profit percentage, we have no other alternative but to manually create the gross profit percentage column. Here, we shall use the formula D15 divided by B15 and copy it to rows below. We have manually created the gross profit percentage column. We want selective analysis. It will work. We shall achieve the same result directly without creating two more intermediate columns by using DAX measures and data model. Select the table, and then go to Get Data. From other sources, select the table/range. The Power Query will open. Go to Load and Close to. A pop-up box will open. Click the radio button, only create connection, and then tick Add to the data model. The data will be added to the data model. Below the thick line, create the first measure gross profit. Gross profit will be equal to sum of sales minus the sum of cost. We shall create another measure, which is the GP percentage, and GP percentage will be equal to gross profit divided by sum of sales. Format the gross profit percentage to 2 decimals. Click Pivot Table. Opt for creating the pivot table in a new worksheet. From Data Table 1, we shall select the fields product, sales cost, and the measured fields gross profit and GP percentage. You will see everything is properly computed. Now, we can do further analysis, and we shall have no problem in doing him. As, for example, we shall select clothes and electronics, and it will show proper data for both the two items. Next, we shall select electronics and furniture, and last of all, we shall choose clothing and furniture. Power Pivot correctly shows the data of gross profit and gross profit percentage. We have understood how to create measures. Now we shall understand how to create calculated columns. First, go to the heading and type gross profit. Select any row, but preferably the first row. Click the sales column and DAX formula will be automatically generated on the formula bar. Then input the minus sign and select the cost column. Again, the DAX formula will be automatically generated. Press Enter and the gross profit for all the rows will automatically be calculated. Go to the next column. Give the heading as GP. Click the first row. Input equal sign on the formula bar. Select the gross profit column and then input the slash sign. After that, select the sales column. The gross profit will be calculated for each row. Click the % button to reduce the number of decimals to 2. We have just now created 2 calculated columns. Here are the summarized difference between calculated columns and measures. Storage. Calculated columns are stored in the data model, static values. Measures are not stored, calculated on the fly. Calculation context. Calculated columns are calculated row by row. Measures aggregates or calculates based on report context. Use case. Calculated columns do row-level transformations or static values. Measures do aggregations, dynamic calculations, or KPIs. Performance impact. Calculated columns increases model size, more memory. Measures increases query time, more CPU. Slicing/filtering. Calculated columns can be used as slicers or filters in visuals. Measures cannot be used directly as slicers or filters. Use calculated columns when you need a value for each row that will be reused in multiple places, as for example as a slicer or filter. The calculation is row-specific and doesn't depend on report context. Example, creating a profit column for each transaction. Profit equals revenue minus cost. Use measures when you need to perform aggregations, as for example sum, average, count, or dynamic calculations that change based on report filters. The result is only needed for display in visuals, not for row-level storage. Example, calculating total profit across all transactions. Total profit equals SUMX, sales, revenue minus cost. When writing DAX expressions, using variables can significantly improve readability and reduce repetitive code. Variables are defined with the VAR keyword, followed by a return section that specifies the final result of the expression. You can define multiple variables within the same expression, and all of them remain local to that expression. It's important to note that variables in DAX are scoped locally. They cannot be accessed outside the expression in which they are defined. In other words, DAX does not support global variables that can be reused across the entire model. We have the data model. We have to calculate the GP% of the total sales. Before calculating the GP%, we shall have to calculate the total sales and total cost and the total gross profit. We can directly create the formula as stated. Alternatively, to make the formula more readable, we can introduce variable within the formula and rewrite it. Let's look at an example. We have a table which has got sales price, cost, and quantity sold. From this, we shall have to calculate the GP%. Select the table. Go to Data, then Get Data, and from other sources. Select from Table/Range. The Power Query will open up. After Power Query is open, go to Close and Load to. Select the radio button, Only Create Connection. Tick the box Add the data to the data model. The data will be added to the data model. Click the data model and click Manage Data Model. We shall compute the gross profit percentage in 2 was. In the first method, we shall use only formulas. In the second method, we shall use variables. So, in the first method, we shall calculate the total sales, then calculate the total cost. Then we shall subtract total cost from total sales and divide the resultant with total sales to get the gross profit percentage. The plain formula is difficult to understand. Now, we shall do the same using variables. So the first variable we shall be creating is the total sales. Then, the next variable we shall create is total cost. Next, we shall define the total margin variable by subtracting total cost from total sales. We calculate the gross profit percentage by dividing gross margin by total sales. For the person reading the formula, it will be easy to understand. Distinct versus values. In DAX, data analysis expressions, values and distinct are functions used to retrieve unique values from a column or table, but they serve slightly different purposes and have distinct behaviors. Here's a clear explanation of their differences. 1. Values. Purpose returns a single column table containing the unique values from a specified column, including a blank row if the column contains blank values. If the column is in a table with relationships, it respects those relationships. Behavior includes blank values if present in the result. Returns a table, single column table, not a list of values. Respects the current filter context unless modified by functions like all or except. If the column is part of a table with relationships, values considers valid rows based on those relationships, e.g., it excludes values that don't exist in the current data model context. Use case. Commonly used in calculations where you need a table of unique values to iterate over, e.g., with SUMX, AverageX, etc. Useful in scenarios where you need to respect relationships in the data model. Distinct. Purpose returns a single column table containing the unique values from a specified column or expression, excluding blank values by default. Behavior excludes blank values from the result unless explicitly included via a calculation or expression. Returns a table, single column table, similar to values. Does not consider relationships in the data model directly. It operates purely on the column or expression provided. Ignores the filter context for the column unless explicitly modified, e.g., using all or other filter functions. Use case. Useful when you need unique values without blanks or when working with expressions that generate values. Often used in scenarios where relationships are not a concern or when you want to explicitly ignore blanks. Difference between distinct and values given on the screen. Please note the first item blanks. It states for values, it includes blank values, while for distinct, it excludes blank values. However, the matter is not that simple. None of the textbooks explain it properly. Today I shall try to explain the difference between the two. The table contains several blanks in the brand column. We shall use both values and distinct function to understand the difference between the two. First, we shall create a measure using values. Click any cell below the thick line and type the formula as shown on the screen. Result is shown as 16, which comprises 15 brands and 4 blank columns considered as one item. We shall now create a measure using distinct. Click any cell below the thick line and type the formula as shown on the screen. Result again shown as 16, which comprises 15 brands and 4 blank columns considered as one item. Hence we see there is no difference between values and distinct. In the textbooks, it is mentioned distinct ignores the blank. But to our surprise, we find that distinct is considering blank. Now, let me explain the reason behind it. On a standalone basis, if a table contains blank, Excel considers it as valid input. Hence, distinct takes the input of 4 blank rows and considers it as one input as unique values are considered. So you do not see any difference between values and distinct. What the textbook forget to mention that distinct only ignores blanks, which are a result of an error. This I shall now explain. We have got 2 tables here. Table A has product and sales details. Table B lists products and brand details. You will notice that several products do not have brand name in Table B. If we join both the tables, there will be several products which will show blank in the brand column. If we use distinct, these blanks are ignored. We shall be using measure, which will unify both the tables. Such unified table will have blank rows. We created a measure using distinct to calculate the total sales value. The distinct should ignore the blank rows. We have also created a measure using values to calculate the total sales value. Value should include blank rows. Now we put to test by creating a pivot table. From the sales table, select Product field. Go to Band table and select Band. Then go to Sales table and select Field Sales Value. Select both the Distinct and Value Measure fields. Go to Pivot Table Options and click for Column Totals. Click OK. You shall observe total of sales values and sales values obtained by using values function are identical as they have considered blank columns in the band column. Now we shall filter out the blanks from the brand column. We find all the sales total are identical. This demonstrates that distinct ignores blanks if it generated by the system. If we remove the brand filter, the total sales obtained by using distinct remains the same, while the sales values using values got increased, as they're now considering the blank rows and band column in the computation. Here we have data model with 5 columns. We need to find a value of total sales. We shall find in 2 ways, one by using sum and another by using SUMX. In the first method, we first have to create a calculated column. Select a blank column and type sales value as header. Then select a cell in the column and type the formula as shown on the screen. Excel will show the sales value for each product. Now click any cell below the thick line. We shall create a measure using sum. Input the formula as typed on the screen. Measure will be created and the sales total will also be shown. Now we shall create another measure using SUMX to find out the value of total sales. Click any cell below the thick line. For SUMX, we do not need a calculated column. Input the formula as shown on the screen. The new measure is created showing the value of total sales. Click the Pivot Table button to create a pivot table. From the field, list select product and the 2 measures. One created by sum and another created by SUMX. Both the measure columns will be identical. We are now going to discuss about 2 functions in DAX in Excel. Average and average X. Average calculates the simple average of a column. Average X iterates over a table, evaluates an expression for each row, then averages. Average does row-level aggregation. Average X grouped or calculated expressions. We have table with 3 columns. First, we shall create a calculated column. Click the header and type the formula as shown on the screen. The formula will be copied throughout the column. Now we shall create a measure called average 1. Click any cell below the thick line. Input the formula shown on the screen. The measure 1 is created with formula. Now we shall create a measure with average X. The advantage of average X is that it does not require the calculated column. Input the formula as shown on the screen. The measure will be created. You will observe the results of both the measures are identical. Calculate function. The calculate function is one of the most powerful and widely used functions in DAX, enabling dynamic and context-sensitive calculations. The calculate function evaluates an expression in a modified filter context. It allows you to manipulate the context in which a calculation is performed, making it essential for creating complex measures and calculations that respond dynamically to slicers, filters, or other user interactions in a data model. We have 3 columns: region, product, and sales values. We shall use calculate function to create a measure to filter out sales of Eastern region. Click any cell below the thick line and type the formula as shown on the screen. The new measure is created. Now we shall explore how to utilize the measure in Power Pivot. Click the Pivot Table button and opt for Flatten Table. From a field list, select Product and New Measure field. As the region is already filtered in the measure, it should not be selected. Let us click Pivot Table Analysis. Select Insert Slicer. In the slicer, select Product. Now you will be able to do product by product analysis of sales made in the East. Filter in DAX is much more powerful than filter in Excel. Here we shall create 3 measures of filters. First is a simple one. In the first measure, we call Create a Filter where we are only interested in sales to USA. Select any cell below the thick line and input the formula as shown. Now, we shall create a pivot table using this measure. This table will concentrate on sales only to USA. From the field table, select Class, Brand and Product. Select the first measure. Go to Pivot Table Options and select Classical Look. We have a pivot table focused on sales to USA. From here, we can do further analysis on sales to USA. Now we shall create a measure, which is more complicated. Suppose we want to know sales made to BRICS countries. BRICS comprises of Brazil, Russia, India, China, and South Africa. Create a new measure using the formula shown on the screen. Create a new pivot table. From the field list, select Class, Brand, and Product. From a measured field, select Filter to. Go to Pivot Table Options and select Classical Look. We have a pivot table purely focused on sales to BRICS countries. From here, we can do further analysis on sales to BRICS countries combined. Now, we shall create a more complicated measure using filters. From the dataset, we would filter out data relating electronic sales to Europe. Create a third measure using the formula as shown on the screen. Create a new pivot table. From the field list, select Class, Brand, and Product. From the measured field, select Filter 3. Go to Pivot Table Options and select Classical Look. We have a pivot table purely focused on electronic sales to Europe. From here, we can do further analysis on electronic sales to Europe. The related function in DAX, data analysis expressions, is used in Power Pivot to fetch a value from a related table based on a defined relationship between two tables. It's particularly useful in a data model where tables are connected via keys, allowing you to bring data from one table into another for calculations or analysis. Here we have two tables, sales and products. Sales table has columns order ID, product ID, quantity, order date. Product table has columns product ID, product name, unit price. Let us click the diagram view. We connect both the tables through product ID. Here we first create a calculated column. We bring the unit price to this table from the product table using related function. On the table header, type unit price. Click any cell in the column and type in the formula as shown on the screen. The formula will be copied across the column. Next, we shall bring in products into this table using related function. Click the header and type product name. Click any cell below and type the formula as shown on the screen. The formula will be copied across the column. We shall now create a calculated column for sales. Input the formula as shown on the screen. The formula will be copied to the entire column. Now we shall create a measure called sales total column. Click any cell below the thick line. Input the formula as shown on the screen. The measure and its value will be displayed. Now we shall create a pivot table. Click Pivot Table. From the Sales table, select Product Name and Measured column of Total Sales. Product-wise total sales amount will be displayed. The divide function in DAX is a smart and safe way to perform division in Power Pivot or Power BI, especially when you're dealing with uncertain denominators that might be zero. Why use divide when there is / operator? Using / directly can cause errors if the denominator is zero. Divide avoids this by returning a fallback value or blank, making your model more robust and error-free. We have a data model consisting of 3 columns. The first column is product, second column is sales value, and third column is units sold. Now we shall calculate the unit price by dividing sales value with units sold. This we shall do in 2 ways. One by using / operator, and another by using the divide function. First, click the header and type unit price using /. Click any cell below. Type in the formula as shown on the screen. Power Query will copy the formula to all the cells in the column. Note in one row the units sold is 0. Anything divided by 0 is an error. This error is represented by infinity symbol. Now we shall create calculated column using divide. Click the header and type unit price using divide. Click any cell below. Type the formula as shown on the screen. The formula will be copied to all rows below. Please note the row which had a problem of dividing by 0. The error is replaced by blank. All function. The all function in DAX removes filters from a table or column, allowing calculations to consider all data regardless of current filter context. Purpose and behavior. Primary role. Clears filters from a table or column in the current filter context. Used in measures, calculated columns, and visual level calculations. Common use case. Calculating ratios or percentages against a total, e.g., sales by region versus total sales. Misunderstanding filter removal. All doesn't return a table of all values. It removes filters so calculations can run over the full dataset. The company has 3 products, A, B, and C. It is selling to 2 countries, UK and USA. Now we want it for USA. Percentage of sales of each product A, B, and C in USA. What is the percentage of USA sales compared to total sales? We are now in data table. The first measure we shall create is total sales. Input the formula as stated on the screen. The next measure we shall create is total global sales. If we use filter, total sales will indicate the sales of the filtered items, while global sales will always indicate the total sales of all items. Input the formula as shown on the screen. The next measure we shall create is global percentage. For all individual product sales, it will show it as a percentage of the total sales. Input the formula as shown on the screen. The next measure we shall create is total specific. It will show the total of items chosen either in the filter or in the slicer, and not total of all items. Input the formula as shown on the screen. The next measure we shall create is specific percentage. For all individual product sales, it will show it as a percentage of the specific sales. Input the formula as shown on the screen. Click the pivot table on the ribbon. Opt for New Worksheet. From the field list, select country, product, total sales, global percent, and specific percent. Select the columns global percent and specific percent and format them into percentage with 2 decimals. Click Pivot Table Analysis from the menu bar and select Insert Slicer. From Slicer menu, tick Country and Product. Click OK. The column Specific Percent shows the percentage share of each product in USA for the sales made in USA. Global Percent shows the percentage of each product sold in USA compared to the total sales. What is RANKX in Power Pivot? Ranks is a DAX function used to rank items in a table based on a numeric expression. It's especially useful in measures or calculated columns when you want to rank entities like products, regions, or salespeople by metrics such as revenue, profit, or quantity sold. Please look at the syntax on the screen. Table. The table in which the ranks function to be applied. Expressions. It is the column in which ranking to be applied. Value. Optional if a specific value to be ranked, usually omitted in row context. Orders. Optional ascending or descending. Ties, optional how to handle ties. We have table with 2 columns. The first column has name of the students and second column shows the marks obtained by the students. We shall now create a series of calculated columns showing all aspect of our RANKX function. We shall create a calculated column showing rank of the students in descending order. Type rank on the header. Select any cell below and type the formula as shown on the screen. The formula will be copied into an entire column, and the rank of the students will be displayed in descending order. Select the next column. Type rank 1 on the header. We shall now rank students in ascending order. Click any cell below and type the formula as shown on the screen. Rank of the students are displayed in ascending order. Now we shall explore if a student got a particular mark, what would have been his rank. Here we are considering 95. Click the column header and type rank 2. Click any cell below and type in the formula as stated on the screen. The rank of the hypothetical mark is displayed. Now we shall explore the ways Excel handles rank in case there is a tie. One way is to continue ranking without skipping. As for example, if 2 persons are tied at the first rank, both are ranked first. The person whose marks are below the first rank holders is ranked second. Select the next column. Type rank 3 on the header. Click any cell below and type the formula as shown on the screen. Rank of the students are displayed without skipping the ranks. Select the next column. Type rank 4 on the header. Click any cell below and type the formula as shown on the screen. Rank of the students are displayed skipping the ranks. You shall notice that ranks in rank column is identical to rank 4 column as skip is the default option. Dated in DAX. The dated function in DAX is a time intelligence function used to shift dates forward or backward in time. It returns a table of dates shifted by a specified number of intervals, days, months, quarters, or years. When to use dated. To compare current period with past/future periods, month over month, year over year, quarter over quarter. To create trend analysis, e.g., previous quarter sales. Works best with a proper date/calendar table, continuous dates with no gaps. We have a table in Data Model, which has got 2 columns. The first column has date, and the second column has sales numbers. The table has sales number from January 1st, 24 to December 31st, 25. Click the Design menu. Click the Date table, and then click New. A calendar table will be created. Click the Date table. Click the menu, Mark as Date table. Select Date as Date data type. Click OK. Click Home button. Select the diagram view. Click the Date column of Calendar table and drag it to the Date column of the Sales table. Now, both the tables are connected. Now we shall create a measure using the function DateAdd. Click any cell below the thick line. Type in the formula as shown on the screen. Now we shall create pivot tables using the new measure. Click the Pivot Table option and then select New Sheet. From the Calendar table, click More Fields and select Year. From Sales table, select Sales field and then Measure field. As there is no data prior to January 2024, no data appears for previous year for year 2024. For 2025, both the current year data and the previous year data appear. We shall create a new pivot table with quarterly summary. From the field list, click the Calendar table and click Year. Then click Date Quarter. From the Sales table, select the Sales and the new measure. You will observe that in 2025, quarterly summary of sales is generated along with the corresponding quarterly summary for the year 2024. Now we shall create a pivot table which will provide monthly aggregation of sales. From the field list, click the Calendar table and click Year. Then click Date Month. From the Sales table, select the Sales and the new measure. You will observe monthly aggregation of sales. For the year 2025, both monthly sales for the current year and monthly sales for the previous year are displayed. If function in DAX. The syntax is if, logical test, value if true, value if false. Logical test, a condition that evaluates to true or false. Value if true, the result returned if the condition is true. Value if false, optional, the result returned if the condition is false. If omitted, DAX returns blank. Switch function in DAX. The switch function in DAX is an elegant alternative to multiple nested if statements. It evaluates an expression against a list of values and returns the result that matches, clean, readable, and efficient. We have two-column data model. The first column contains the name of the students and second column contains the marks they have obtained in maths. The task is to convert the marks into grades as per the matrix shown on screen. This we shall do using multiple nested if. Click the column header and type grade to create a calculated column. Select any cell below. Type the formula as shown on the screen. Click the tick mark to accept the formula. The grades will be displayed as per the matrix. What we demonstrated is a very complex nested if function which may be difficult to understand. We shall now demonstrate how to obtain the same result using switch function. We shall create another calculated column. Click the column header and type using switch. Click any cell below the column and type in the formula as shown on the screen. Click the tick mark to accept the formula. The grades will be displayed. We have 3 columns dataset. We shall explore the effect of count and its related functions on the dataset. Count counts the number of rows in the specified column that contain non-blank values. Counta counts the number of rows in the specified column that contain non-blank values, including Boolean. Countax. The countax function counts non-blank results when evaluating the result of an expression over a table. That is, it works just like the countif function, but is used to iterate through the rows in a table and count rows where the specified expressions results in a non-blank result. Count blank counts the number of blank cells in a column. Countrows. The countrows function counts the number of rows in the specified table or in a table defined by an expression. Countx counts the number of rows that contain a non-blank value or an expression that evaluates to a non-blank value when evaluating an expression over a table. We shall create 3 measured column using count function. Click the cell below the thick line under the column header order ID. Input the formula as shown on the screen. Count is 5 as all the rows are filled. Click the next column and type in the formula as shown on the screen. Count would return 3 because there are 3 numeric values 100, 200, 300. It ignores the 2 blank cells. Click the next cell and type in the formula as shown on the screen. Count would return 4 as there is only 1 blank cell. Click the next cell under order ID column. We shall explore countif function. Type in the formula as shown on the screen. Counter would return 5 as all cells are non-blank. Click the next cell. Type in the formula as shown on the screen. Counter would return 3 as there are 3 non-blank cells 100, 200, 300. Click the next cell. Input the formula as shown on the screen. Counter would return 4 as there are 4 non-blank cells Alice, Bob, Charlie, David. Click the next cell under order ID column. We shall explore countax function. Type in the formula as shown on the screen. Countax would return 5 as all cells are non-blank. Click the next cell and type in the formula as shown on the screen. Countax would return 3 as it evaluates the expression amount for each row and counts non-blank results. Click the next cell. Input the formula as shown on the screen. CountX would return 4, as there are 4 non-blank cells: Alice, Bob, Charlie, David. Click the next cell under the column order ID. We shall create measure using CountLength. Input the formula as shown on the screen. CountBlank would return blank, as all cells are non-blank. Click the next cell. Input the formula as shown on the screen. CountBlank would return 2, as there are 2 blank cells. Click the next cell and enter formula as stated on the screen. CountBlank will return 1, as there is 1 blank cell. We shall now create measure using CountRows function. Click a blank cell below the thick line under the column order ID. Input the formula as stated on the screen. CountRows would return 5, as there are 5 rows in the dataset. We shall now create measure using COUNTX function. Click a blank cell below the thick line under the column order ID. Input the formula as stated on the screen. COUNTX would return 5, as it counts rows where the column is non-blank. Click the next cell. Input the formula as shown on the screen. COUNTX would return 3, as it counts rows where the column is non-blank. Click the next cell and input the formula on the screen. COUNTX would return 4, as it counts rows where the customer column is non-blank: Alice, Bob, Charlie, David. Max function. Purpose returns the largest numeric value in a column or from a set of values. Maxa function. Purpose returns the largest value in a column, including logical values and text. Max function. Purpose returns the maximum value from an expression evaluated over a table. We have 4-column table. Products are sold across 3 cities. We shall find the highest price of the product across 3 cities. However, in DAX, you can compare only 2 columns at a time. To compare 3 columns, we have to use the nested technique. Click the header and type max of 3 calls. Click any cell below the column and type the formula as shown on the screen. Highest price of each product across cities will be displayed. Click any cell below the thick line. We shall create a measure max 1. Type the formula as shown on the screen. The measure will display highest value in column city A. We shall create another measure max 2. Input the formula as shown on the screen. It will show the highest number across all products and cities. Concatenate text is a powerful DAX function used to concatenate text values from a table or expression without adding an extra column in Power Pivot. Also, it can be used to combine concatenated text separate by comma. We have got a table of 2 columns. First column contains first name and the second column contains the surname. The table has 3 rows of data. We have already created a data table. First, we shall create a calculated table to show the full name, combining the first name and the surname. Input the formula as shown on the screen. Full name will be displayed in the calculated column. Now we shall use measures using concatenate text function to combine the text of two columns without using any extra column. We shall create two measures, the end result of which will be same. Click any cell below the thick line. Input the formula as shown on the screen. The first measure is created. Click any cell below the thick line. Input the formula as shown on the screen. The second measure is created. Click Pivot Table icon. From the fields, select First Name and Measure 1 and Measure 2. You will observe row by row the full name is displayed both under Measure 1 and Measure 2. Also observe under Grand Total, all the full names are displayed separated by delimiters. In this video, we shall demonstrate 7 logical functions in DAX. They are isBlank, isLogical, isNonText, isNumber, isText, isError. Column 1 has data type blank. Column 2 has data type Boolean. Column 3 has number in text format. Column 4 has numeric data. Column 5 has text. Column 6 is a calculated column. Is deliberately made into error. If you look into the equation, it is column 4 divided by 0. We shall now look into first logical formula isBlank, which returns true if the column is blank. We shall now look into its logical function, which returns true or false if the column has Boolean data. Next function is isNonText. Column 3 contains text. Here 1 is input as text. Hence the answer is false. Next function is isNumber, which validates the existence of numbers. Column 4 contains number. Hence the answer is true. Next function is isText, which validates the existence of text. Column 5 contains text in number format. Hence the answer is true. Next function is isError, which signifies the existence of error in the column. We evaluated calculated column 1, where we deliberately created an error. The result is true. Is the list of my social media accounts. Feel free to connect with me. If you find a video useful to you, please click like, subscribe to my channel, and press the bell icon to get notification as soon a new video is uploaded. Feel free to leave your comments to improve my channel.